In this video, we will go over how to introduce custom materials into the Autoline 1D and ST materials database. In order to successfully implement a new material, the following information about the given material is required: molecular weight, density, first charge capacity, first discharge capacity, and the particle diameter. You also need the OCP curve of the material, the entropic heat generation, the exchange current density, and the diffusivity of the material in the form of either a lookup table, a function, or a constant value. To get started, we'll open the materials database editor within the Autoline GUI, where we see a complete list of the existing materials inside the database. We'll click Add a Material and proceed to entering in the properties of the new material. In this example, we'll create a new material for NCA, so I'll enter the name here and fill in the rest of the parameters. The Umax input you see here is essentially the starting point on the OCP curve, which corresponds to a fully charged cell. Lastly, we'll define whether or not this is a positive or negative active material. Once this is done, we can click Save Update to officially modify the database, and if we come down to this positive active material selection, we can see that NCA is now added to the list. The next important thing to do is modify the UDF files to account for the new material. If you remember, any new custom material requires an OCP curve, diffusion coefficient, exchange current density, and entropic heat generation term, which is input through the UDFs. We'll start by first modifying the OCP curve. In this example, we'll use a lookup table which will be read in from a CSV file. Let's open up the file and take a look at what's inside. The lookup table should consist of 2 columns with no text anywhere in the file. For a custom OCP curve, the data which is used as the OCP data is plotted versus the stoichiometry. The y-axis can have any value, but the x-axis must start at 0 and end at 1 in order for the table to work properly. In this case, our data was taken from experimental measurements. In the actual UDF file, first we'll modify the name of the material by changing NCM to NCA. And then we'll copy and paste the path of the CSV file into the lookup table section of the UDF. Keep in mind that if you don't have a lookup table available, you can just as easily use an equation or function taken from literature. Once this is done, we can move on to inputting the diffusivity, exchange current densities, and entropic heat generation terms. For these parameters, we'll use equations taken from literature. One of the most important things to remember here is to update the actual name of the material within the UDFs, which in this case is NCA. Once you've saved your files, simply continue setting up the rest of your case as you would normally. You can switch the OCP, diffusivity, and exchange current density parameters to UDF, but even if it's set to database, the software will automatically read in the UDFs for the custom material. And that should be it. We will build our new UDF file and then run the simulation. This process can be repeated for any desired material for either the positive or negative electrode, as long as the required information is available. Thanks for watching.